Hi everyone, welcome to the playlist on backtracking. In this video, we'll start with the problem of subsets. So given a set of numbers 1 to 3, right, we need to return all possible subset, which is 2 raised to 3, 8 subsets we'll get, right? So we'll start with the plain backtracking template, like the solver function that we write, and then we'll see another variants of how to solve this problem. So let's start with the setup of the problem. I say okay, I will have some output and the solver will fill this output. It has to make decision from 0th number. I will give some partial and it will fill the output and will return the output. This is the setup, right? And now my solver, let's write it. I have idx, I have some partial number and I have output. So if my idx is greater than equals to length of nums, which means I have consumed all the numbers, right? So I will add the partial into my answers. This is done, right? Otherwise, what I do is either I don't choose the current element, right? So this is like the plain setup, right? Key, I don't want to choose the current elements and tell me the number of subsets. So I add idx plus 1 and my partial remains same and output is output, right? So I made the chosen part here, explore also, and unchoose. All of them has been done here because I didn't choose anything directly, right? But I had made this decision of not choosing the current element by jumping on to idx plus 1. Otherwise, I will choose something which is I will add nums of idx, okay, which is I made the choose part here, okay, let's write correctly, okay. I made the selection and now my solver will go from idx plus 1 partial output, and this is like the explore part, okay. Once I'm done, I will pop the current element, which is unchoose part, right? So once this is done, let's see if it works. Okay, something happening with partial dot append to end append here, okay. Let's submit it. Awesome, it works. Let's see another technique to solve this problem. I will write a different, like the function will remain the same, but the agreement from the function will be different, which is I have my nums, I have idx and partial output. What this function says is, hey man, I have already made the decision from nums from 0 to idx minus 1, and now you just need to expand this by at least 1. Whatever subsets you have, just expand it by 1 and keep adding them. So what I mean by this is, let's write it. I say okay, for I in a range of idx to length of nums, I need to choose every element. At least I have to select one element, right? So what I do is I append nums of I have chosen nums of I, choose part, okay, and now I start exploring nums from I plus 1 to partial of output, okay, and now I pop it, which is unchoose, okay, and here I made the explore part, right? So what I'm doing is whatever the function I'm calling with idx, right, whatever my partial is, I need to add something to it, which is like, okay, I just expand it by 1 and then call it, and then the other function will again expand it by 1 if it is possible. And what happens is I will always have my answer. So my output dot append will be partials copy, because I started with the 0th length subsets and now I started adding one element, which is like first I added 1, 2 and 3. I was removing others, right? So I created subset of size 1, then the function was creating subsets of size 2 and 3, so on and so forth, right? But first it went from, okay, from empty I created 1, and from 1 it created 1 2, and from 1 2 it created 1 3, and then reverted back and it went to 2 3 and so on and so forth, right? So this was like another setup. Let's see if it works. Okay, let's submit it. Awesome, it works. So let's see the code which will translate into non-recursive code. So which is like what I do is I say, okay, hey man, create a solver which will return me the output also, right? Which is solver of nums, and I start my decision from 0th element. I say okay, I have nums and idx, and if idx is greater than or equals to length of nums, okay, I will return empty subsets. Otherwise I get my subsets from all the elements to the right, okay, I got it. And for subset in subsets here, I will add this subset, and I will add my current num also to each of the subset, which is like, okay, I'm making the do not, okay, this part is do not select the current element. Okay, this is select the current element. Okay, so this is it. Once I'm done, I will return the output. Let's see if it works. Okay, let's submit it. Awesome, it does. Let's jump to the non-recursive part using this template. This will be the setup we'll be using for non-recursive part. So for that, let's get rid of this. And now what I say is, okay, I have output which is this. For each num in nums, what I say is my output is output plus nums of, let's say, num plus o for o in output. Once I'm done, I return output. This is like very small code here. Okay, so let's see if it works. Okay, let's submit it. Awesome, it does. So guys, this was like very small code, right? But we had this journey of solving it with multiple variants. I hope guys you like this solution. If you like this, please hit the like button and subscribe to my channel for more videos. See you next time.